When you are solving linear equations, there's several scenarios that you're going to see. One where they ask you just to solve for x, and a second scenario where they ask you to solve for an expression in the form ax plus b. So something other than just x, like you're finding a whole expression. So if you're solving a problem where you're just finding x, all you need to do is look to combine your like terms and then isolate your variable, and that will give you your solution. So here for a problem like this, we isolate our variable, just divide both sides by 8, reduce what we have. 10 over 8 reduces to 5/4, and so that would be your solution. You can also use Desmos if it's in the calculator portion. If you type in 10 equals 8x, you can just scroll here. You see your answer is 1.25, which is just the decimal equivalent of that. Now, if instead it's asking you to find a specific expression instead, then what you're going to look to do is you'll perform whatever operations are needed to see if you can directly create that expression. This will usually be just straightforward adding, subtracting, multiplying. And you're looking to put one side of the equation into whatever form it's asking you. So if we look at this equation right here, and they want you to solve for 1 minus 2x. So notice it's not just asking you to find x, it's asking you to find that expression. And so what we can do is look to see on the right side of this equation, so 6 minus 12x, what do I need to do to this side here to get my expression 1 minus 2x? Well, the way that we can do that is if we divide everything by 6, we get the expression 1 minus 2x, and so we'd have to make sure we do that to every single term in the whole equation. So negative 18 divided by 6 leaves a negative 3, and so that's the value of our expression 1 minus 2x. You don't have to solve for x and then plug it in. You can. If we were to take our equation right here and we take negative 18, set that equal to 6 minus 12x. Here we see that our x value is 2. So if we are solving this the traditional way, we get x is equal to 2. And so then it becomes, evaluate this expression. 1 minus 2 times 2 gives us 1 minus 4 or negative 3. And so that would be the alternate way to solve this. Now, in addition to this, there's another type of linear expression or a linear inequality to solve. If this is the case, then what you are looking to do is just to isolate your variable. And remember, when this happens, you do have to keep in mind that if you multiply or divide by a negative, that means you have to change the inequality. So it'll change from a less than to a greater than, or a greater than to a less than. And the other thing to keep in mind is the form that you get it. If you are isolating the variable to the right side, most of the time they'll ask you to rewrite that variable on the left. And so if you think of how does x relate to a, well, here the inequality symbol is going to open toward x. And so if you reevaluate or if you rewrite it, you have to make sure that it is representing the same relationship. Okay, so a problem like this is just finding that specifically. If we isolate our variable, we can divide both sides by 2. That leaves us a negative 9 halves is greater than x. But notice all of these answer choices are written with the x first. So if we put x and compare it to the negative 9 halves, the inequality symbol is pointing to the x. And so this is the form of the expression that we're looking for. In the problem next, what we see here is that if we look to solve this by hand, you can just isolate your variable. So if we subtract 52 from both sides, we get negative 3x is less than negative 66. Divide both sides by negative 3, and you get x is, remember, because we divided by a negative, we have to flip that inequality symbol, so now it becomes greater than, and a negative 66 divided by a negative 3 is positive 22, and so we get x is greater than 22. Now we can also use Desmos for inequalities. So if we took that original inequality, 52 minus 3x is less than negative 14, notice we see on our solution here that the graph begins at 22 and x is to the right of that, so greater than 22, and you see the dashed line means there's no equal to, and so that would confirm our answer. When we are looking at these linear word problems, the one thing just to be aware of is that you're using the correct units. So if they give you 3 feet but they ask you to solve the problem in inches, you need to be able to make that conversion. So just be aware of that. So here, if we look at the first example, it says that Chi-Chi spent 6 more hours practicing guitar than Will. So C is equal to Will plus 6. I'm going to express it that way. And then it says if Chi-Chi practiced for 14 hours, so C is equal to 14. What you now know is you can substitute in and write your equation. Now notice on the in the answer choices, the variable x represents the number of hours for Will, so we're going to replace the x here for the w. And notice all the variables are on the left side of all of these equations. So if I take this x plus 6, that's equivalent to c, which has a value of 14, and so I see what my answer choice is when I evaluate this. And next it says John read the first 114 pages, so I know that I expect my right side of the equation to be 114. And this is 3 pages less than, so I know I'm subtracting 3 pages from something. 1/3 of the novel, well, it's 1/3. If the novel has p pages, we get our expression 1/3 p minus 3 is equal to 114, and that would be your solution. And then finally here, it says you have a weeping willow that's 15 feet in height, so that's the starting point is 15. Notice again, based on the form of my answer choices, we begin with 15. It grows a maximum height of 35 feet, so that means that the limit is 35, and you see that's the case for all of those options. And then it says it grows at a constant rate of 24 inches, but we're working in feet. So 15 represents feet, so that means that it's going to add 24 inches is equivalent to 2 feet. So we're adding 2 feet per year, so it's plus 2. Just make sure you don't mistakenly take 24y because we're working in feet, not inches. All right, next we're dealing with working with linear functions. Again, just keeping in mind here that a linear function has the form ax plus b, where a is whatever the rate of change is, and b is the initial amount, or the starting point. And the rate can be a rate of change. It can be a rate where it's a price per, or the gallons per. It's some unit some unit of rate. Okay, so here it says in the first example, Finn and Gabby are selling raffle tickets if Gabby sold 17 fewer than Finn. So if we looked at Gabby is equal to 17 fewer than, so less than, Finn, which will represent as F. So here's one relationship. And then second, it says, so if we're looking to find which of the answer choices shows this form, again, what you see is F and G are on the same side for all of these. So if I move F and G to the same side with F written in front, that means that I am simply going to put the F over here, so negative F plus G equals negative 17. And to get my F to be a positive, I change the sign of every one of these terms. So I get a positive F, a minus G, and a positive 17. And so that gives me my answer choice B for this problem. And the next it says here that you have an equation, a function to represent this scenario. And in this scenario you have a base salary plus a commission. Well, the base would be your starting point. The commission would be, in this case, 500 per what C represents, which is chairs. And so you can see very quickly that the base salary is this 40,000, and then you earn an additional 500 per chair sold. Okay, next, if we go to this problem, you have this equation where you have the distance, and it says that the D represents a remaining distance, so you're going to start with some initial amount, and it gets reduced by 38 units per time. And so here we know that the initial amount is 220, so that's the original number of meters. And then the negative 38 is the rate of the change. So what we see is that's the speed change in meters per second. And so that's just interpreting what the formula means, and it's 38 meters per second change. Here, when we look at this problem up above, you have this expression 12G, giving the kilometers a car can travel using G liters of gas. And so we just apply that directly. So if I replace G with this 5 1/2, we can either think of it as 5 1/2 is 5.5, and do the calculation here. 5.5 times 12, we get 66 for our solution on that problem. And then finally here, this last example, or this last problem, you have this given equation that represents meat patties here. And so instead of using it in this form where it's, or in this factored form, we can go ahead and expand it through. And so this is really just 38 times 25 minus 38 times D, where D represents the number of days after restocking. And so what this tells you is that this whole quantity, which if you needed to know it, you could calculate it as 38 times 25. So that 950 is what the number of patties it starts with, and then it reduces by 38 per day. And so if we are interpreting what does that mean, the 38 means the number of patties decreasing per day is 38. Right, the next concept has to do with slope, and there's a couple things. Slope can be calculated if you have the coordinates. It's just the difference of the y's over the difference of the corresponding x's. So we could calculate that slope. You may also find that the slope can be interpreted if we put it in the slope-intercept form. And so here, the coefficient of x when you solve for y is your slope. And you can also set up a Desmos table. I'll show you how to do that here in just a moment. And the other thing to keep in mind with regard to slopes is sometimes you just need to know the tendency of a slope. So a slope that goes up and to the right is a positive slope. If a slope or a line goes down and to the right, then here the slope is going to be negative. If you have a flat graph, the slope is 0. And finally, if you have a vertical line, the slope is undefined. So sometimes you just need to know the tendencies if you need to identify a graph by its slope. All right, so let's take a look at these two examples here using our calculation. So the first one, you're given these 2 points, so we could just use our equation for the slope, and that is m is equal to the difference of the y's. So we see 10 and 2, so 10 minus 2 over the difference of the corresponding x's, which are 4 and 2. And so 10 minus 2 is 8, 4 minus 2 is 2, and that gives us a slope of 4. Now, we could also solve this one by setting up a table and creating some values. So if you don't remember the slope formula, but you understand how the tables work, if we hit this plus symbol and create a new table and label the 2 points that we have. So an x coordinate of 2 corresponds to a y coordinate of 2, an x coordinate of 4 corresponds to a y coordinate of 10. Once you enter those two things in a table, those 2 points in a table, you can use the linear regression, which is y1 is similar to. Again, the similar to button can be located in this drop down. It's not on the main screen, but if you hit the alphabet keys, it's located right here. And then if you type in m for slope times x1 plus b, if you just type the general form of a linear equation, it actually gives you that slope is 4, the y-intercept is -6. And so it would confirm that we're dealing with a slope of 4 here. In the other problem here, in this one, to find the slope, you're simply going to take the given equation and you're going to solve it for y. So if we isolate the y, we add 7x to both sides and divide everything by 2. We get y to be 7 halves x plus 5 halves, and that gives us our slope of 7 halves. All right, next we're dealing with this the graphs of linear functions. So remember, you have a couple different forms of graphs. You have slope-intercept form, y equals mx plus b. If this is the case, you have this graph where you have the y-intercept here, which is the point 0b. And that graph will have a given slope of m. And you could also have a graph where it's given in this general form, ax plus by equals c. This is going to allow you to find the intercepts. So again, if we have the graph here, we have these two intercepts. The y-intercept is where x is 0. And so if x is 0 here and we solve for the remaining y is equal to c over b. And if we wanted to find this x-intercept, the x-intercept occurs when the y value is 0. And so if we let this y value be 0 and solve for x, we would get c over a as that intercept. And finally, the last possible form that you might see would be point-slope form. So point-slope form looks like this, y minus y1 equals m times x minus x1, where you have a given slope of m, and you have a point that passes through, or a point on the graph, which is x1, y1 set of coordinates. So if we look at these problems here that are shown, the first one that we see is asking which of the following relationships can you identify? Well, here we're given this form in the ax plus by equals c form. And so we're likely going to use the intercepts. We know that if you let x be a 0 here, which would cancel this whole term, and then we solve for y, we simply need to multiply both sides by a negative. So y is going to equal -8 for that. And if we let the y be 0, meaning we let this be 0 and solve for x, we would divide both sides by 2. And so that would give us x is equal to 4. So this would be our x-intercept and y-intercept here. And so when you're looking at these, you see that the x-intercept is 4 and the y-intercept is -8. Those conditions are met from what we see in the example. Now, if neither of those would work, then we could go in and look for the slope. If we were finding the slope, we would take that equation and solve for y. So if we isolated the y and then change the sign of every term, notice we do get that the y is equal to -2x minus 8. So the slope would be a -2, and that is not true for these answer choices. If we look at the second example here, now we're told the x and y intercept, and so if we know that the x-intercept is negative 2/7 and the y-intercept is 8/7, these are the points that correspond. The x-intercept has a y value of 0, the y-intercept has an x-coordinate of 0. And so what we can do right here is we can just plug these in and test the points if we want to and see what works for this. So if we let x be a 0 in each of these instances, so if we look at all of these instances where x's are 0, we can disregard these. We want to find which of the possible solutions leave a y value of 8/7. Well, we see 8 would leave an 8/7, option A would leave an 8/7, option B would leave an 8/7, but the other two would be negatives. So we can eliminate those choices. Okay, we can then go do the same exact thing with the second point, the x-intercept. So if we let y be 0 in these remaining two and test which of these gives you a remaining value of x of negative 2/7, the only one that would work is this first one. The other one would give you a positive 2/7, and so that means that A would be your solution. And now you could also solve this problem using Desmos pretty easily as well. If you were to plot these points, so the x-coordinate is negative 2/7, 0, and the y-coordinate is the point, or the y-intercept is the point 0 and then 8/7. Okay, so what we were able to do here is we plotted these 2 points. We see them, I'll zoom in. So here's the 2 points plotted. And so all we would need to do is if we just type each of these possible equations and see which one passes through both of those points, what we would see is if we took, oops, let me see what those equations were originally. So if we took 7y minus 28x equals 8, you can see that that actually passes right through. So we'd have our answer with that first one, but if we tested the remaining 7y plus 28x equals 8, that one does not pass through. We could test the remaining two. So here negative 7y plus 28x equals 8, again does not pass through, and finally negative 7y minus 28x equals 8 also does not pass through both of these points. Okay. So when you look at the ones that pass through, or the only one that passes through both the x and the y-intercept right here that are designated is that green line, which is option A. Okay, the next equation here, or the next problem here, is dealing with a problem that is in point-slope form. And so what you can see from this is we have a slope of 1/5, and we have a corresponding point that the graph passes through that is the zeros of each of these quantities. So the value of x that gives you a 0 here is -5. The value of y that gives you a 0 here is 2. And so these are the pieces of information that are shared or that are given by the point-slope form. And so it's just a matter of here the graph has a slope of 1/5, yes, and it passes through the point -5, 2. So option C is the one that has both of those pieces of information. Okay, and then this final problem, again, what you can see here is you see your y-intercept. You also see your x-intercept, but here, because the answer choices are given in slope-intercept form, we know that -2 is our y-intercept, so we can eliminate options A and C. And then it's just a matter of which one has a either negative slope or positive slope. If we go back to the slope tendencies, when the slope goes down and to the right, it's negative. That means that this slope, the coefficient of x has to be a negative number. So the only one that remains with a negative slope is option D. Right. When you are working with slopes, you also need to pay attention to parallel lines. Parallel lines are going to have the same slope, which means that if the original slope is a over b, then the slope of the parallel line is also a over b. And so these are lines that never intersect. And perpendicular lines are going to have slopes that are negative reciprocals. And so if the original slope was a over b, then the slope of the perpendicular is going to be the negative, the opposite, and the reciprocal. So flip the fraction to b over a. And so when you're looking at these problems, you'll use whatever it takes to find your slope, and then if it's dealing with parallel or perpendicular. So first one, we want a parallel line, so we need to find what the original slope is. We're given an equation, so we're just going to solve this for y. Subtract 3x, move the terms to the other side, and then divide by 2. And when we solve that, we get our slope on this to be negative 3/2, which means the slope of our parallel line is going to be the exact same, negative 3/2. And so if we eliminate any slopes that are not negative 3/2, notice we are left with just the 1, which means that's the correct answer. In the second example, we're given an equation and a point, and we're asked to find perpendicular to the given line. So if we take our given line and find this slope, which is equal to negative 3, that means that the slope of the perpendicular is going to be positive. Change the sign and flip the fraction, so positive 1/3. And if it passes through this point, what that means is that we can go in and either plug in, so we know that the slope has to be 1/3. That means we can eliminate the two options where that's not the case. So it's either B or C. And you could either plug the point into each of these. So if we evaluate 6, 3 here, we can see, is 3 equal to 1/3 times 6 plus 5? Or is 3 equal to 1/3 times 6 plus 1? Well, which of these is a true statement? You get 1/3 of 6 is 2. 2 plus 1 is equal to 3, so this one is the true statement. Here, 1/3 of 6 is 2. 2 plus 5 is 7. 3 does not equal 7, so that would eliminate that choice as well. Right. When we're dealing with systems of equations, we will tend to use the Desmos calculator to help us with this. Okay, and then just keep in mind that if you do get some form where x is equal to a, this means that there's one solution. If you're solving and you get if the variables cancel, okay, so if the variable terms cancel, then you're going to have one of these two scenarios. And if the constants are two different things, so if the constant on the left is different than the constant on the right, so it's not a true statement, then that means that these are parallel lines and there is no solution. And if you get a statement where the two constants are the same, so the constant on the left and the constant on the right are exactly the same, then that means that these are the exact same line. Okay, they overlap each other, and that would mean that there's infinitely many solutions. Okay, so when we are solving system problems, first thing to look for is just plugging the system into into Desmos and seeing where they intersect. So one way to solve this is if we just take our equation x plus y equals 3, x minus 3y equals negative 9. We can see where these intersect on our graph. They intersect right here at the point 0, 3. And so our solution will be 0, 3. That's the easiest approach to this. If you're not going to use the calculator on this problem, you could solve this system using the different methods. You could also plug in points. So if you test the different points and verify that they work, you could do it that way as well. But since Desmos is available here, we're going to use it. So if I take the second equation and just type what I have, or exactly as it appears, I don't have to simplify anything. So there's my first equation. My second equation is 2x plus 3 equals 11. Okay, and when I solve for this, I see the intersection is 4, -4. Okay, and so 4, -4 are the coordinates, and if I want to find x plus y, I simply take 4 plus a -4, which is 0, and so my answer choice would be option B. Right, next, in these questions, these are more similar to the patterns up here. If you are looking for a system where there is no solution, what needs to happen is first the variable terms need to cancel, and then for no solution, the second thing is the constants need to be different from each other. So if I take this problem right here and I say, what would A have to be so that these cancel each other out? The easiest way to approach that is simply to, again, enter these on your calculator. You can enter unknowns, like we can keep y as a variable here. Okay, notice it prompts you to create a slider. If you just hit enter, it'll pull that slider up. And this will be some random value. I'll talk about what that value is. It starts off as a 1, but you can change it. Our second equation in this system is y equals 2x plus 2, and it's asking what would that have to be for there to be no solutions. Well, we can see right here, just as a equals 1, these are parallel lines, they're never going to intersect, so it's no solution. So we wind up getting our a value is equal to 1, and that is the solution. It won't always be that case. You may have to change this slider if you click on the box here and change the step to 1 so that it doesn't go by decimals. Right, and then you can go in and you can change this. Notice as I move this, what happens to that line. The line adjusts, and if I want to get a parallel line, I can see that the answer would be 1. Okay, if we do the same thing with the second problem, same idea over here. We take and just type the equation directly in to Desmos. So here's the first equation. Type in the second equation again, just copy exactly what we have. Notice it has an A again, that's fine. Okay, it prompts to create a slider. Again, I'm going to do that. I'm going to change this step to 1 so it slides by a value of 1. Now notice what I'm looking at right here is I want one that has infinitely many solutions. So now I want this to be the same line. These two lines have to overlap. So as I start to slide this, notice I'm moving away from where I need to be. I want these to overlap. So as I keep sliding it across, I get my overlap right here. And so that means that A is equal to 4, and that would be your solution. So using Desmos to help with these will also be a nice, efficient way to answer these questions. All right, next we have these linear inequality word problems. They're very similar to what we did with the linear equality or the linear equations. Okay, and so it's just a matter of representing what's given in terms of the inequality. So here it says Dorothy wants to make at least 24 sausages. So the number of sausages has to be greater than or equal to 24. We know that the comparison, the number that's comparing to is on the right side, so we know that this now eliminates 2 of these options, the ones that are less than. Okay, and then it says that each sausage weighs 12 ounces. What's the total weight that she needs to buy? So if we know that we are taking whatever our number of, whatever the total amount is, and divide each one by 12, that will give us that we get a total of at least 24. And so we can see that we're dealing with this ratio here, x over 12 is greater than or equal to 24. And when we look at this second example here, you have more than 450 students, so we know again we're comparing to 450 We want that expression to be more than 450, so once again we know that it's going to be either option A or C. And it says that the school allows 6 students to travel by car, so we're letting 6 go by car and the rest on 11 buses, each which held the same number. So we're going to take 11 times per student on the bus, plus the 6 who went on their own cars, and so we see that option A is represented by that inequality. Next we look at this problem here, and again just interpret what we have. It says Aaron is purchasing party hats and fake mustaches, and he can spend a total of 30, so at most 30, so it has to be less than or equal to 30. So once again we can eliminate the options where we're not using the less than or equal to 30. And it says that the fake mustaches cost $3 each, so 3 times the number of fake mustaches, or M, sorry, that's represented by M, the mustaches, and then $2 per hat, so plus $2 per hat. And so here, oops, they have it as party hat. And so I have 3M plus 2P, 3M plus 2P compared to the 30. So right now I can see my option is A, but I can go ahead and confirm it using the other. Their combination has to be at least 15 mustaches and party hats, so M plus P has to be at least, so it's greater than or equal to 15, and once again that confirms that option A will work. Okay, the final example here, a website that offers digital movie rentals for $2.95 per movie, so $2.95 per X, and we're comparing that to a set fee of $12.95, and we want to find what's the minimum number of movies so that you're saving money by using the service. So we want to find where the $12.95 is less than what it would be for renting per movie. So it's less than or greater than or equal to when you're looking at the cost of the movie per. We want to find where is that greater than the cost of the unlimited movie fee. So if we just divide both sides by 2.95, we'll find our answer. And so if we took $12.95 divided by 2.95, we get X has to be greater than or equal to 4.39. That's the cost. And so in this particular case, or that's the number of movies, you can't rent a partial movie, so we need to pick what's the value of X that is greater, the lowest value of X that is greater than or equal to 439, and that would be 5. The next concept here is looking at graphs of systems and inequalities. Once again, let's take advantage of Desmos. Okay, and so if we type in what we have, x minus y is equal to 1, there's our first equation, and then 2x minus y is equal to negative 1. There's our second equation. What we can see right here is we have an intersection of, the solution has to be at negative 2, negative 3. So again, if we go negative 2 down 3, that doesn't show the solution. Negative 2 down 3, that one does. Doesn't mean that it's correct yet. So this is a potential. Let's eliminate all the others. Negative 2 down 3, that one doesn't work. And negative 2 down 3, that one also doesn't work. So the only one that does work here would be option C, based on what we see from the plot. And we can do the same thing with the inequalities. Okay, if we take our given inequality and type this in, so y is greater than or equal to 3/10 x plus 5. So there's our first inequality. And our second one, y is greater than 5x minus 7. And so here we see the intersection. The solution is the part that's shaded both blue and red. So this purple region is your solution. And if we want to find which of these points satisfies the inequality, what we can do is we can also plot each of those points and see which one falls in the solution set. So here, this one actually falls right on it, but let's confirm that the other ones do not work. So 1, 1 falls only in the blue. 3, 8 falls on this dashed line. The system can't have a solution on the dashed line. And then finally 10, 6. That falls, here we need to scroll out to see it, that falls outside of everything. So the question is asking which of these is satisfied, and so the one that does work was that very first one, which is option A. And then the final question here asks to find which of these, in which quadrant will there be no solution to this inequality. So we're going to look at both of these, or we're going to look at the inequality as a system. So if I type each one in, y is less than or equal to negative 3x minus 4. So there's my first inequality. The second one, y is less than or equal to 3x plus 8. There's my second. And so once again, when you look at the solution set for this, is this shaded region of both. And so that includes this little bit that's in quadrant 2, this little bit, or this large amount in quadrant 3, and this amount in quadrant 4. So the only quadrant that doesn't have any solutions is going to be quadrant 1. And so that would be your choice for this.